Hello students, welcome to my study channel. Today we will study chapter 3 of the mathematics book of class 8 and the topic is Understanding Quadrilaterals. So this is chapter 3. Understanding Quadrilaterals. So we will discuss about quadrilaterals. So what do you know about quadrilaterals? You know quadra means 4. You see quadrilateral means a four-sided polygon. So what is polygon? Already you know it. You see polygon. Poly means many. Poly means from the Greek word you see, and polygonia means angles. So polygonia means polygons with many angles. Four-sided polygon. So what is polygon? Polygon it is a simple closed curve. Simple closed curve or figure which is made up of line segments. And you see there are different terms here it has been used. You see simple curve, closed curve, and already you know what is line segment. Okay? So before going to polygon, let us discuss, you see, regarding the curves. You see, in layman's language, a curve, that means that is not a straight line. But in mathematics, a straight line can be a curve. A curve can be straight line. We can call it in mathematics. So you see, in the starting of the first page of that topic, you see, there are some figures like this. So you see, all are curves here, and you see here, it is a straight line, and it is also bent here. So it is also a curve. It is also a curve. It is also a curve, and it is also a curve. And you see, simple curve, then complex curve, just opposite. Often curve, just opposite, closed curve. Just we are studying about the curve. Simple curve or complex curve, open curve or closed curve. You see, simple curve, when the curve intersects itself, you see, there is no intersection here. You see here, there is no intersection here. But here is the intersection, because the intersection point is here. Let the point you see, the curve cuts itself, intersects itself. So it is the point of intersection. So it is not a simple curve, but it is a simple curve. It is a simple curve. It is a simple curve. But these two the second one and the fourth one. These two are not simple curves. Why? Now they have the point of intersection. So the curve should not intersect itself. Such type of curves are called simple curves. So we pointed out two curves which are simple. Then come to complex. It is a complex curve and it is also a complex curve. Why? Now there is the point of intersection of the curves. So it is about the difference between the simple curve and the complex curve. Then come to open curve and closed curve. You see, this is the, let it be the starting point. That means the beginning point. Let it be the point A and it is the point B. And you see, the curves begin and end at different points. That is the open curve. So it is also an open curve, the second one. Let it be C and D. You see, if it starts from here and ends at here, both the cases you see, the curve begins and ends at different points. So the curve which begins and ends at the same point, such type of curve is called closed curve. So here you see, it is the closed curve. If you take it this point as the starting point, let it be A and give also that point to B, both A and B point are the same point. So a curve begins and ends at the same point. Such type of curve is called closed curve. But when the curve begins and ends at different points, such type of curves are called open curves. So it is all about simple curve, complex curve, open curve and closed curve. But when we study now about the polygon, that should be a simple closed curve. And that is a plane figure. That is a plane figure. Because you know the paper is a model for the plane surface. And you see, it is also a plane surface. You see, this whiteboard is a plane surface under. So the polygons are the plane figures. So we will study about that. So that should be simple. That should be closed, simple curve. That should be a closed curve, and that is made up of line segments. Then we can call that this figure is a polygon. And also you can see in the first page it has been given like this. The straight line, straight path. And these are the polygons. But which are not polygons, it is on the right side. Already it has been given in the book. Consider as the straight line, straight path. You see, first point, it is a simple curve or not? You see, it is a simple curve because the curve doesn't intersect itself. There is no point of intersection. So first, it is a simple curve. And you see, it is a closed curve because the curve begins and ends at the same point. And these are the line segments. You see AB, DC, CD and DA. These are the line segments. Yes or no, part of the lines. So these are the line segments. So this is a polygon. This is also a polygon like this. This is also polygon. But why it is not a polygon? Why is it not a polygon? You see here. Is it simple figure? Is it a simple curve? No, because the curve intersects, there is a point of intersection here. It is not a simple curve. Next point, it is not a closed curve. If you start from here and you end at here, both the points are not the same point. So, the curve begins and ends at different points, so it is not closed. And this curve is not simple, but it is made up of line segments. No, all the conditions are not satisfied, it is not a polygon. And here you see it is a complex curve because the curve intersects itself, okay? And it is closed. Yes or no? But it is not a simple curve, but it is made up of line segments. So it is not a polygon. Here you see it is not closed. It is a simple curve. Yes? It doesn't intersect itself. This curve doesn't intersect itself. It is a simple curve. It is made up of line segments. This curve you see. But it is not a closed curve. But a figure to be polygon, it should be a simple closed curve which is made up of only line segments. So then we can call it as a polygon. Okay? So what is quadrilateral? The quadrilateral means it is a four-sided polygon. Quadrilateral is four-sided polygon. So we go to different. We'll classify polygons according to the number of sides or vertices. So the simplest polygon is the triangle. You see, it is made up of line segments. It is a simple figure or not, or simple curve, and it is a closed curve. Three conditions are satisfied, so it is a polygon. So the simplest polygon is the triangle. So triangle is the simplest polygon. But we will study today about quadrilateral, four-sided polygon. If it is so, suppose n is the number of sides. N is number of sides of the polygon, or number of vertices of a polygon. So n is equal to 3. Either 3 vertices you see, here it is one vertex, one vertex, one vertex. So there are 3 vertices A, B and C. There are 3 points, 3 vertices. So also it has 3 sides. So number of vertices is equal to number of sides. You may tell number of sides or number of vertices. So when n is equal to 3, so it is a triangle which is the simplest polygon. When n is equal to 4, suppose like this, I am drawing any common quadrilateral. Yes or no? You may name it like this. So here n is equal to 4, that means 4 vertices, or you may tell 4 sides. So you will call it as quadrilateral. So that's it. This is triangle, simplest polygon, and this is quadrilateral. And if n is equal to 5, you will call it pentagon. If n is equal to 6, hexagon. n is equal to 7, heptagon. N is equal to 8, octagon. Octa means 8. If n is equal to 9, nonagon. If n is equal to 10, decagon. So you may name like this according to the number of the vertices or the number of the sides of the polygons. And if n is equal to 11, that is hendecagon. If n is equal to 12, you tell it as dodecagon. Then tri, tetra, penta, hexagon, hexadecan, decagon, hepta, decagon, octa, decagon, and for 19. You may tell nonadecagon or enneadecagon, and for 20, what you will tell? Icosagon. You may tell icosagon. Like this, you will name the polygons. Suppose this is a closed curve. This is a closed curve, and you see this part, the interior part, this interior part, this is the interior part, this is the interior part, and you see this boundary, this is the boundary line or not? Or this is the boundary of this closed curve. So interior part has the boundary, but these are the exterior part, and the exterior part has no boundary. The interior part has the boundary, but the exterior part, these are the exterior part, here is the exterior part, here, which surrounds. So the exterior part has no boundary, but the interior part has the boundary. Okay? So when we are reading the chapter 3, Understanding Quadrilaterals, and just it is a four-sided polygon, and we are just discussing about a polygon. Then we will move to the quadrilateral. You see, polygon, convex polygon, and concave polygon. Generally, we deal with the convex polygon, and you will see in the convex polygon. How do you know that this is a convex polygon? So what is polygon? You better know it, because it is a simple closed curve which is made up of line segments. But in case of convex polygon, you will see that suppose we will start from the quadrilateral, because there is no diagonal in case of a triangle, that is also a polygon. So from the quadrilateral just we are starting, you see, you cannot find the diagonals in its exterior part. Always you will find the diagonals of that polygon in its interior. You see, suppose this is a polygon. It is a quadrilateral. It is a four-sided polygon. And you see, ABCD is a quadrilateral. Suppose you take the point B, that is the vertex B, and you tell me, with respect to B, A is one consecutive point or consecutive vertex, and it C, the point C is also a consecutive vertex. So for point B, if you move from point B, then you will meet here the point C, or you will meet here point A. You cannot, you do not have the direct contact with this point to this point. You see in this figure. So from B you may move to C, from C you may move to point D. So which are two consecutive points of the point B? Now point C and point A, or point A and point C are the consecutive points of B. For the point C, point B and point D are two consecutive points. So the line segment joining two consecutive points for B, for the point B, the point A and the point C are two consecutive points. Yes or no? For the point B, the point A and the point C are two consecutive points. But the line segment joining two non-consecutive points becomes the diagonal. You see, for the point B, this is one consecutive point, this is other consecutive point, but the point D is not the consecutive point. So these are the two consecutive points. So through the ruler, with the help of the ruler, just you connect it, this line segment. So this is a diagonal because both the point B and the point D are non-consecutive points. So you see, for the point A, B and D are consecutive points. For point C, both B and D are two consecutive points, but both A and C are non-consecutive points. So you join with the help of the ruler. So this is a diagonal. So what is diagonal? It is a line segment joining two non-consecutive points. So we are getting two diagonals here for a quadrilateral. And you see, these two diagonals are in the interior of the polygon or not, of the quadrilateral or not? Yes. So it is a convex polygon because we can find the diagonals in the interior of the polygon. But in case of concave polygon, we will have the at least one diagonal that will be in the exterior part. You see. For point B, point A and C are two consecutive points. For point D, point C and point A are the two consecutive points. But both point B and D are non-consecutive points or not? Just you join with the help of the ruler. Does it lie in the interior of this polygon ABCD? No, it is in the exterior part. But the point A and the point C are two non-consecutive points. You join both the points. So this diagonal AC lies in the interior, but the diagonal BD, you see this line segment BD, doesn't lie in the interior, it lies in the exterior part of the polygon. So it is the example of a concave polygon, and in your course we will deal with the convex polygons. Okay. So now we'll study about regular polygon with irregular polygon. So a regular polygon has equal sides and equal angles. That means a regular polygon is both. It is equiangular and equilateral. Equiangular and equilateral. Equilateral means the sides are of same measurement and equal angles, that is equiangular. That means the angles are of equal measure. So we may see now this is the length of AB is equal to length of BC is equal to length of AC. And you see it is a regular polygon. Okay? And in case of quadrilateral, we may see a square. All the sides are of equal length. That means the length of AD is equal to length of AB is equal to length of BC is equal to length of CD. All the sides are of equal length. So this is also a regular polygon and it is called a square. And like that, suppose we will draw a hexagon here. So all the sides are of equal length. So first, a regular polygon has equal sides and you see sides are equal, then equal angles. That means in case of a equilateral triangle, the angles are of equal measure. In case of a square, you see each angle is 90 degree. And in case of a regular hexagon, it is a regular hexagon. It is a six-sided polygon and all the sides are of equal length, and also this is a regular hexagon. That means this regular hexagon, it has equal sides and it has equal angles. That means this regular hexagon is equiangular and equilateral. So you see these interior angles are of equal measure. Okay. So in case of irregular polygon, suppose this is 1, 2, 3, 4, 5, 6. So this is also a hexagon. But This is irregular hexagon. Why? Now you see the sides are not of equal length, and the angles you see here, the interior angles you see here, these are not of same measure. So this is an irregular hexagon. But in case of a regular hexagon, the hexagon is both equiangular and equilateral. That means the regular hexagon has equal sides and equal angles. So this is all about irregular and irregular polygons, and just we will know about angle sum property. In case of a quadrilateral, we can say that the sum of the measures, of the interior angles of a quadrilateral. It may be convex one or a concave one. The sum of the measures of the interior angles of a quadrilateral is 360 degrees. PQRS are the four vertices of this quadrilateral, and you see, just you construct a diagonal by joining two non-consecutive points. So this quadrilateral is divided into two triangles. Let this angle QPR, this measures, let it be angle 1, this is angle 2, this is angle 3, and this is angle 4, this is angle 5, and this is angle 6. And you see, in the triangle PQR, okay, in the triangle PQR, you see, measure of one angle plus measure of two angle plus measure of three angle, that is equal to 180 degree. And in the triangle PSR, measure of angle 4 plus measure of angle 5 plus measure of angle 6, that is equal to 180 degree. Okay, so if you add, what will happen here? You see, angle 1 to measure of angle 1 plus angle 4 plus measure of angle 2 plus measure of angle 5 plus measure of angle 3 plus measure of angle 6, this is 6, that is equal to 180 degree plus 180 degree. So that implies, you see here, measure of angle 1 plus measure of angle 4, that means this is this angle, measure of angle P. So you see, this is the measure of angle P plus measure of angle 2, this is measure of angle Q plus measure of angle 5, here it is 5, we'll write, we'll go here, you see, measure of angle 3 plus measure of angle 6, this angle, this is measure of angle R, plus measure of angle 5, that means measure of angle S. that is equal to 180 degree plus 180 degree. That means that is 360 degree. You see, both P, Q, R, S are four interior angles of this quadrilateral. So what you came to know? That the sum of the measures of the interior angles of the quadrilateral is 360 degree. So it is most important, and also in the NCERT books, in different ways it has been proved. You see, this is a point, and the sum of the measures of angles about a point, that means all the angles, you see, measure of this angle plus measure of this angle plus measure of this angle and measure of this angle. So the sum is 360 degree. Okay? Already you can do this, already it has been given here. Take four congruent cardboard copies of any quadrilateral ABCD with angles as shown. Arrange the copies as shown in the figure, where angles 1, 2, 3 and 4 meet at a point. You can also do this, and basing on this, we may also prove like this. Take any point, let it be P, just to connect with the help of the ruler to draw the line segment. Let it be angle X, this is Y, this is Z, and this is W. Okay? And suppose this is angle 1, this is angle 2, this is angle 3, this is angle 4, this is angle 5, this is angle 6, this is angle 7, and this is angle 8. So we can see here 1, 2, 3, 4, 4 triangles. So what we will do here, you see. Measure of angle 1 plus measure of angle 2 plus measure of this angle X is equal to 180 degree. That is the angle sum property of a triangle. The sum of the measures of the interior angles of a triangle is 180 degree. So if measure of angle 1 plus measure of angle 2 plus X in which triangle? In APD. In triangle APD. This is the triangle APD that measures 180 degree. So that implies, what is the measure of angle X is equal to 180 degree minus measure of angle 1 plus measure of angle 2. Like this, we can also prove, you see, X is equal to 180 degree minus 1 angle plus, no need to write here measure, no letter has been given here, using the number we are writing. So angle 2, measure of angle 2. For this triangle, I can also write 180 degree minus angle 3 plus angle 4. Like this for Z, for this triangle BPC, I may write 180 degree minus angle 6 plus angle 5. Angle 5 plus angle 6. Then come W, bring W here, that is 180 degree minus in this triangle A, P and B. angle 7 plus angle 8. And we will add, so you see x plus y plus z plus w, that is equal to 180 plus 180 plus 180 degree plus 180 degree, that is 180 degree into 4 minus, okay, so minus of this, minus of this, so minus of, we'll add all these, you see, angle 1 plus angle 8 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7. Already we have covered 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All these. So it's okay. So what happened? I just bring here this sum. That means angle x plus angle y plus angle z plus angle w. You see, this is around a point or not? You see, this angle plus measure of this angle plus this angle plus this angle plus this angle, 4 angles, x, y, z and w. The sum is 360 degree. So it is 180 degree into 2 or not? So by transposing this, I can write here, you see, angle 1 plus angle 8, that is measure of angle A, plus 2 plus 3 plus D plus measure of angle 4 plus 5, that is of C plus D, that is equal to, that means we transposed to the left hand side, so it was minus and it will be plus in the left hand side. So what will happen here now? 180 degree into 4 minus 180 degree into 2. You use the distributive law, that is 4 minus 2 or not, that is equal to 180 degree into 4 minus 2 is 2, that is 360 degree. So the sum of the measures of the interior angles of a quadrilateral is 360 degree, whether it is a convex quadrilateral or concave quadrilateral. So it is all about, and we will go in the next video. We will go through the exercise 3.1. We will do the solution, we will discuss the exercise questions and we will solve it. So okay. So if you have not subscribed my channel, please subscribe it, and wish you all the best. We will meet in the next class.